Good morning. Hello, everybody. I would like to welcome you all to our workshop, En-ROAD workshop. Today, we will talk about the En-ROADs and digital transformation. En-ROADs developed by Climate Interactive and MIT Management, Massachusetts Institute of Technology Management, Sustainability Initiative. Today, I am planning to make speech together with an introduction, En-ROADs introduction. Later on, I will give brief information about climate change, and I will come the main subject, digital transformation. I will start with digital transformation, and I am planning to continuing En-ROADs and digital transformation, using En-ROADs for digital transformation research and papers, and of course, together with conclusion, I will finish my presentation. Let's start with En-ROADs. En-ROADs is a cutting-edge simulation model used to test climate solutions and generate climate scenarios for the future. En-ROAD is an interactive climate solutions simulator developed by Climate Interactive and the MIT Sloan Sustainability Initiative. It helps users explore the potential impact of different climate policies and solutions on global temperature rise, greenhouse gas emissions, and other key climate metrics by 2100. With En-ROADs, users can model the effects of policy changes in areas like energy sources, transportation, industry, land use, and carbon removal, allowing them to see how different strategies could work together to limit global warming. En-ROAD is used by policymakers, educators, business leaders, and the public to explore what-if scenarios, promoting a deeper understanding of complex climate systems and trade-offs associated with different strategies. It's known for being accessible, scientifically rigorous, and designed to foster dialogue about climate action. Until now, we organize 6 workshops related with En-ROADs. We started with hybrid workshop on climate change and simulation of its scenarios using En-ROADs tools. The first presentation, November 2022, November. For more information about En-ROADs and how it works, you can watch our first workshop video. Easily, you can reach it from YouTube. This is our, as you see, this is our link. Easily, you can download and you can remember what did we do before. We continued, as I said, the other En-ROADs presentation periodically. May 2023, we organized the second one, hybrid workshop series on climate change and simulation of its scenarios using En-ROAD tools 2, from theory to practice. For more on how to practice En-ROADs, you can watch our second workshop. This is the link. You can download easily and you can watch this video. The other presentation, November 2023, and it was about practice on smart city. For more on how to practice En-ROADs on smart cities, you can also watch our third workshop video. And this is the link of this video. You can download easily from the YouTube. And this is another topic. We changed each presentation, we select the top hot topic subjects, and it was related with transition to sustainable energy. For more on how to practice en routes for energy sector, you can also watch our fourth workshop video after download this link. One more other presentation was related transition to sustainable energy. For more on how to practice en routes for the energy sector, you can also watch our fourth workshop. Another presentation, it was related with application in civil engineering. For more on how to practice en routes on how to practice en routes in civil engineering, you can also watch the fifth workshop. The final one, it was presented this year, April 2025. The subject was Water Energy Food Nexus. For more on how to practice en routes in Water Energy Food Nexus, you can also watch our sixth workshop video after downloading this link. I gave some information about the former en routes workshop, and let's come to the second topic, climate change. Climate change, in the middle part of our presentation, it's important issue for us. You have to know a little bit the climate change. What is the meaning of climate change? Climate change refers to long-term shifts and alterations in temperature, precipitation, wind patterns, and other aspects of the Earth's climate over extended periods, typically decays to millions of years. Currently, the term often describes recent and ongoing warming primarily caused by human activities, particularly the burning of fossil fuels, deforestation, and other processes that release greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. These greenhouse gases trap heat within Earth's atmosphere, creating a greenhouse effect that leads to global warming. This warming affects weather patterns, causing extreme events like intense storms, droughts, heat waves, sea level rise, and shifts in ecosystems and biodiversity. While natural factors like volcanic eruptions and solar cycles have influenced climate in the past, the rapid changes observed in recent decades are primarily attributed to human action. This figure shows us the mechanism of the greenhouse effect. Some solar radiation is reflected by the Earth and the atmosphere. Most radiation is observed by the Earth's surface and warm it. Some of the infrared radiation passes through the atmosphere. Some is observed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. The effects of climate change can have significant social, economic, and environmental impacts, affecting agriculture, water resources, health, and infrastructure, especially for vulnerable populations and ecosystems. Addressing climate change involves mitigation and adaptation. Now let's come to the main topic for today, new topic. We will focus on the digital transformation. Digital transformation, let's start to give some information. Digital transformation is reshaping the world at an unprecedented pace influencing how scientists communicate, learn, work, and govern. It refers to the global shift from traditional analog system to digital ones, an evaluation powered by digitalization, which is the process of converting information and activities into digital formats. Together, these forces are driving a new era of connectivity, innovation, and efficiency. Digitalization affects every aspect of daily life. The rise of the internet, smartphones, and cloud computing has made information instantly accessible across the globe. Education has expanded beyond classrooms through online platforms. Healthcare now uses telemedicine and digital records, and governments deliver services electronically, improving transparency and participation. In cities, digital technologies support smart infrastructure, managing traffic, energy, and waste more efficiently through data-driven systems. At the global level, digital transformation has also revolutionized economies. Digital markets, cryptocurrencies, and e-commerce have created new opportunities for trade and employment, while automation and artificial intelligence have increased productivity in nearly every sector. However, these advances also raise concerns about privacy, cybersecurity, and inequality, as access to digital tools and skills remains uneven between countries and communities. Ultimately, digital transformation is more than a technological shift. It is a social and cultural revolution. As digitalization deepens, the world becomes increasingly inconnected, creating both possibilities and responsibilities. Ensuring that this transformation benefits everyone requires inclusive digital policies, sustainable innovation, and a shared commitment to bridging the global digital divide. Now, the second topic, en-routes and digital transformation, new second topic. En-routes represent a powerful example of how digital transformation can contribute to solving complex global challenges. Through digitalization, en-routes translate what's scientific data into an accessible, interactive platform that allows policymakers, researchers, and citizens to visualize the outcomes of different climate action in real time. Digital transformation has enabled the creation and wide use of tools like en-routes by combining data analytics, system modeling, and user-friendly digital interfaces. Instead of relying solely on traditional reports or static analysis, decision makers can now use digital simulations to test policy scenarios such as renewable energy expansion, carbon pricing, or reforestation, and immediately see their effects on global temperature, emissions, and economic growth. The interactive nature of En-ROADS reflects the broader potential of digitalization in promoting transparency, collaboration, and education. By making complex climate science understandable, it empowers people to participate in informed discussions and encourages collective problem solving. Moreover, digital platforms like En-ROADS support international cooperation by providing a common database foundation for climate negotiations. In essence, En-ROADS exemplifies how digital transformation enhances our ability to address sustainability challenges. By merging technology, data, and human insight, it bridges the gap between science and policy. This digital approach not only accelerates learning and decision-making, but also strengthens global efforts to create a more resilient and sustainable future. Let's come another topic, using En-ROADS for digital transformation, research, and papers. Beyond En-ROADS' value in climate education and policymaking, En-ROADS offers an innovative digital platform for academic research related to digital transformation. It demonstrates how digital tools can reshape the way scientific data is modeled, visualized, and communicated in research environments. In digital transformation studies, En-ROADS can serve as both a methodological and conceptual tool. Researchers can use it to analyze how digitalization through technologies like renewable energy systems, smart grids, and carbon tracking platforms affects global sustainability outcomes. The model's interactive, data-driven interfaces exemplifies the essence of digital transformation, integrating complex datasets, enhancing accessibility, and enabling evidence-based decision-making. For academic papers, En-ROADS provide a dynamic environment for scenario analysis. Students and researchers can design simulations to test the impact of digital technologies on emissions reduction, economic transition, or behavioral change. The result can then be incorporated into research papers as case studies, graphical visualization, or policy insights. This not only strengthens the empirical foundation of digital transformation research, but also demonstrates the practical value of digitalization in tackling real-world problems. Ultimately, using En-ROADS in digital transformation research highlights the growing role of digital tools in advancing interdisciplinary scholarships. It bridges climate science, technology, and policy, showing how digital innovation can support more transparent, data-driven, and collaborative research for a sustainable future. Now, this is my last part of presentation, its conclusion. And digital transformation is redefining how humanity understands and responds to global challenges, and tools like En-ROADS illustrate its immense potential. By combining digitalization, data analytics, and interactive modeling, En-ROADS transforms complex climate science into an accessible and actionable resource. It demonstrates how digital tools can enhance research, education, and policy development by fostering transparency, collaboration, and data-driven decision-making. In the broader context, digital transformation extends beyond technology. It represents a shift in thinking, communication, and problem-solving across societies. When used in academic research, En-ROADS exemplifies how digital platforms can bridge the gap between theory and practice, helping scholars explore the impact of digitalization on sustainability and innovation. Ultimately, integrating digital transformation with tools like En-ROADS strengthens global capacity to design smarter, more equitable, and more sustainable solutions for the future, linking technology, science, and humanity in pursuit of resilient work. Thank you very much for your attention and participation. Now, Dr. Farhad Bolouri will present En-ROADS simulation. Thank you again.
Hello everyone, welcome to our workshop, and thank you so much Professor Dr. Hüseyin Gökçekuş for their valuable information at the base of the digital transformation. That is our workshop's topic today. And now I'm going to share my screen and go to En-ROADS, which is we can practice what we learned from Professor Gökçekuş's slides in practical part. Now I share my screen, and after that I will go to En-ROADS website, and I will show you how to work with this tool for this information. I think now my my slides can be shown for you. My screen. I'm checking when it's shared with you. I will open the website and show. If the website is showing to you, yes. Yes, if you come to Google and just write En-ROADS, you will see in the first part the En-ROADS website. If you enter to the website, you have here something about them. I want to just show you the stuff of this one because of showing the importance of this tool. For example, here we have senior advisors, John Esterman. Professor John Esterman is MIT professor from MIT who did this system dynamics in 1916s. So now you can see which strong information and model we have in En-ROADS. Also, if you come to here and to ambassadors, you can see here the ambassadors. I am one of these ambassadors. We have around 1,000 people from all over the world, from more than 90 countries. But now I'm going to directly to En-ROADS to show you the simulation. If you come to here, they update it every month, and in every month, so many times they update it. This version is 25.11. It means this month they updated this. Because always they are updating to be up to date, the information, the modeling and everything. We have more than 14,000 formulas behind this. This model is working based on a system dynamics model, which is a tool for system thinking, to seeing everything together. Because of the time, we couldn't every time repeat the system dynamics and the formulas, but if you want, as Professor mentioned before, you can watch our first workshop. In that workshop, we explained what is system thinking, what is system dynamics, which formulas are behind this strong tool. But now I'm directly going to show some task and dashboard, and after that I will go to modeling what we learned from the slides of Professor. First of all, what we have here, we have different languages of this tool. The English one is the strongest one because everything is in English. If you want, you can change it even for Turkish, Persian, and the Chinese in each of the languages we have. But if we change just this dashboard and some of these things will be changed. But if you go to, for example, for more information, here it will not be changed and will be in English. You must know that. Also about the simulation, we have policies. These are policies. This dashboard is your policies. So if you change something and you want to get back from here, if you said reset policies, everything will be go to the first place. Reset assumptions, we have some assumptions. I will go there. Also, you can reset all policies and assumptions by clicking this one. What is the assumptions? Because we have more than 14,000 formulas, we have so many assumptions in this case, in this modeling. For example, I say air pollution from energy. Or for the other things, for example, here we have afforestation.
To make full screen.
Yes, fully screen. Yes.
Let's make more clear. Yes.
Yes. Even for this modeling, you can take it in full screen, but I will show you when we go there. I will show you one by one. Yes. For example, in here, I open one of them: air pollution from energy. You say, for example, in one UN report or in one paper, I read that the coal is not this amount. It is, for example, 29. You can put it here. It is out of there. Yes, it is maximum can be 18. So we put it 0.16, for example. Or you can change bioenergy to, for example, 5, if it is possible. Yes. You can change, and if you change assumptions, this one will be in blue color because it shows that you changed something. But if you reset them, yes, everything will be reset for you. For the graphs, from here you can change. They have more than 100 graphs, and you can choose each one you want. Or from here, you can change it to each graph that you want, for example, this one. And anything that you want, you can choose from here. I return to the first ones. Also from, these are all about the graphs. We will discuss them now when we are modeling here. Also for view, you have main graphs like this. Also you have Kaya graphs. You know, in research, these are so important for you. These are Kaya graphs. I make it full screen. It's better for showing. These are Kaya graphs. When we change these things, you will see the change. We will work with them later. Now, if you go, yes, miniature graphs you have here many graphs, and if you click in which of them, it goes to that one directly. But sometimes we use these ones because you have here so many one, and you can choose directly which you want to focus on it. Here we have the actions and comments. What I did here, these are my actions, what I did as policies. Also, what is the outcomes of these ones? It shows to you. Even you can copy paste in your report and everything. You have actions and outcomes. After that, you have metric units and US units. We are working with metric units, so we don't have any problem. Also, you can choose to not showing the graph tooltips, but we need it. Also, you can say play sounds. When you do a good action, a good policy that it is positive for you and reduce the climate change effects, it will be like this, if you can hear it. And if your policy is negative and it is not a climate action and it increase climate change effects, it will be like this. You see, these are negative things. But this, yes, for example, this one is positive action. But if we reduce renewables in our life, it is a negative action, and you will hear like this. And I close the sound because we don't need it. Also in the help part, you have so many things. For example, En-ROAD user guide, some videos you have, related examples, training you have, even you can be an ambassador of En-ROAD in the future. I don't want to go these things because it takes our time and we don't have enough time for this. If you click on this one, all of the policies will be resetting. This one make your graphs to the first graphs that you had. This one's just one action they give you back. This one gives your action one by one, step by step to the last action that you did. This one is about the last action you did and reset. It is between them. This one is doing the full screen or minimizing it that we need the full screen. Also from here, you can see the miniature pictures, figures that we have, but we will discuss them all. So I am going to first one. Yes, this is the first one. We have global sources of primary energy because this model based on energy. The base of it, the foundation and the main part of the modeling that we have with so many formulas and feedback loops and the other things, but the main part is focusing on energy. This is an energy base model. Because of that, you see here everything about the energy supply. Even here, your transportation is about the energy. Your building industry is about the energy. This one's, yes, about the population and economic growth. Also here, carbon dioxide and the other things are related with carbon dioxide and energy. These are, and also here you have the greenhouse gas net emission as a main graph for you. And here you have the temperature with Fahrenheit and degrees Celsius that we have working with this one. What's important for us is degrees Celsius because we use it in our reports, research, and the other things. Now I want to show you something that this model is so complex. First of all, you can do something that you have in your mind. For example, you say, I reduce coal, I reduce oil, I reduce, for example, natural gases. Also, I'm using more bioenergy. I'm using more renewable energy. I will reduce my nuclear. I will increase my net zero carbon actions. Also, I will increase, for example, carbon prices. For energy efficiency, for example, in transportation, I will increase my energy efficiency. I will increase my electrification. What is our topic today? Digitalization, electrification, and these things. Also in building, what is important for us in civil engineering and environmental engineering, we say, for example, to empower and increase energy efficiency in building, electrification in building. And we say we don't have so many information about population. Population has a negative effect, but we couldn't run off that. So we say, okay, we have a bit increase in it. Also in economic growth, I will say you economic increase has a bad effect on your topic. I will say to you why. Also about the natural base things, you say I will increase it. And for this one, that each of these dashboards, what means to you, each of these policies, you have here triple dots. If you click on them, you can say, for example, natural-based carbon dioxide removal. What it means, it's written here. Also, you have here the graphs that you change. You can change them. Also, if you come here, you have information. For example, what is the examples for natural-based things? Also, the methods that you have, big message that you have about them, key dynamics that you have, because it is a system dynamics model. You have the dynamics, for example, if you see impact, delay in system dynamics, delay is important, that it is the result and your policy making time. For example, you do something today, but maybe you will see the result 30 years later. For example, in afforestation, you are doing some trees and the others nowadays, but you can see the result 20 years later. Scale of that one, the land needed, because it is about the land needed. You have here potential co-benefits of this policy, also equity consideration. You have slider settings that you have here, and you can change them. You have the message here, model structure, they talked about it, afforestation and reforestation that are related to that. Case studies that they have about it, for example, they see the New York City, USA, how many trees they have, which percent they can increase it, future answer and questions they have, and footnotes and everything. You see that you have for all of them this thing. If you click on triple dot and you click in the information part, you have this information for all of the policies, which help you to see what is the important in this one and what it means. In these 3 sentences they said what is it, and also after that you can go to information part and see what is it related to it, what is the feedback loops that you have in system dynamics behind it, and everything. Even from here you can change more things. For example, for transportation energy efficiency, we said, okay, we will do it 4% per year. But for start here, the assumption is 2026. But you say, no, I can do it. I'm a, for example, policymaker. I am a municipality person, but I can do it from 2020 or 2035, for example. You can enter it here because it shows that it will be start, for example, 10 years later, not from tomorrow. These are the things that you can change, and even here, if you change any assumption, as you see, it will be in blue color. Also about the carbon dioxide removal, we say, okay, we will increase our technological part. We will decrease our waste and leakage. We will decrease our agricultural emissions. And what is the important about the agricultural emissions are methane gas. Why it is important? Because, you know, in the earth, the main part that we have about the methane or CH4 is from the cows and the other animals that we are producing for our food. Because of that, some of the environmental activities going to be vegetarian, something like that, because most of the methane and the other things, especially methane, is not coming from burning oil, coal, and the other things. It comes directly from the animals that we are producing for our food. Because of that, this part is important. Also for afforestation and deforestation, because nowadays we don't have so many afforestation in the world, but we have so many in deforestation in Amazon and the other parts in the world. So for deforestation, you can see from here what it means. when you cut the trees for your firms and the other things, you have a deforestation. You say, okay, I will decrease it. If these policies that you are imagine you put here, first time you can do it like this. You don't need to exact numbers to put in the model. Just do like this, and if you do it, you are playing a game. And here you can see it is 1.8 by 21st century. It will be 1.8, which is good because UN IPCC ask the world to be below 2 degrees Celsius. So with this information, yes, between 1.5 and 2, Professor mentioned it now. Yes, UN IPCC, they ask between 1.5. 1.5 is the best, and if it is less than 2, it is good for us. Even, yes, acceptable for us. Even if here we can see the that figure. Yes, in impacts part, temperature change. Yes, as you see here, it mentioned. These are what UN and IPCC expect from us. This is 1.5, the best, and this one is 2, that is acceptable. So when you do these policies in the worldwide, you have 1.8, which is between these two, and it is good. But if you don't do any of them, it comes to 3.3.
Catastrophe.
Yes, and 2 times more than this, and it is 2 times more than which UN and IPCC and world expect us. So you can do this. This was as an introduction for you. You can just do these ones and see how it works for you, this model. But now I am going to do some examples, some more detailed things that related directly with digitalization. So first of all, I repeat them, all of them to the first place. I reset them. You can reset them from here too. Yes, all of the assumptions and policies resetting. Yes, one thing before I forget, I want to mention it. I said about economic growth and, for example, these gases. You know, when we increase carbon price, what is what we did before in United States of America, in Europe, they are doing nowadays. They increase carbon price. With this policy, as you see, it is very good policy, and we have so many decreases here, and it is so good if you see in the first time. But when we have economic growth and people are rich in our words, for example, this one you see, this effect decreases. Why it happens? Because when we have carbon price increases only, what it means, big firms, big companies coming to pay money for their carbon production. So it forced them to reduce carbon production, and it is good policy. But when you have economic growth, it means that your company, for example, Apple, Amazon, or any company, they have good money, they have big monies. So they say, okay, I will produce carbon, but I will pay for it. I don't have any. For example, Microsoft and the others doing these things, they have carbon price tax in United States, but because they are so big companies, they pay it, so they don't care about it. Because of this, you must understand this model when we say 14,000 formulas we have behind it. And when we say it is a complex system, it is a tool for system thinking. Because of that, we say, because of the complexity that we have behind this model. Only with one policy, you couldn't say, I solved this problem. Even it is not enough if you just maximize the carbon price to the maximum one, which is, you can see here, $250 per ton carbon dioxide. Even with this policy, you can increase it, but you couldn't reach your 1.5. And the other policies will come to stop this policy, to reduce its effects by these things, because these things happening behind what you did. One policy can stop the other policy or decrease its efficiency. These are the important things. Also, now I want to discuss with the impacts and the other things that we have here about the graphs. Even for graphs, I want to share before getting some policies. Here, if you click in this part, you can see the information about these graphs. For example, for greenhouse net emission, if you click, it says, what is it? What is it? Base model. It comes from where, for example, it comes from IPCC report in 2021, and the other things they have for calibration. They use these ones because in model, just doing the model is not important. Your calibration is so important to see it works exactly for you or not. If you click even here, you have the history ones. For example, for energy, yes. As you see, for greenhouse gas net emission history in 1990s, from 1990s till 2023, for more than 30 years, they do this. What is the historical data in yellow one, and what is the modeling En-ROADS is the black one. As you see, it covers it, so it is calibration is good. Also, if we come to, for example, our first graphs, if you do some policies, I'm doing some just showing something about the figures to you. If you have some policies like this and these ones, and you come to do this, yes, from here, from 3 dots for each figure, also you have something to do. Even you, the first place you have description that we have from here too. Second one, if you click it, and you can see the nows when we are now. It shows like this. The other one, view it in the larger part. You can show and you can take a screenshot from this ones. Also, you have in a new window, they show for you like this. Even you can copy paste it. Also, I want to show you another important thing. You can copy data from here. It is important when you want to use it in a paper. It is not good to take a screenshot from here. It is better to put the data in an Excel file. I don't want to go because when I go in, maybe my connection stopped. Because of that, I don't want to go. But I will show you. You will copy data from here. And if you go to an Excel file, directly you can paste it. You don't need to change anything. If you paste it, annually you have the data in your Excel file. And this is important for you because you will use it in your papers and reports as a calibration, for example, for your results in your reports and research papers. Now I am resetting everything. And I come to main one. Yes, if we have, I want to show another thing. Yes. Imagine that we did these things from the first until the end. Yes, these ones. But what we have here, for example, in impacts, you have so many good relations and information that you can use. For example, if you are in a health field, for example, deaths from extreme heat, that in recent 10 years, 2 times we had in European countries, that so many people, thousands of people died by the extreme heat. So if you see this one, deaths with extreme heat, if we don't do anything with 2100, we will have around 26 deaths per 1,100 people per year. But if you do these policies, it comes to, for example, around 13 deaths per 100,000 people per year. So you reduce it to half. It is important. Also, for example, in the impact part, I want to show you sea level rise, for example, or flood risk maps. Even for these ones, we can use this one, miniature. Yes, I want to show you here something that is related with your field, and you can use it. It is an online map, and what we want to use, we want to see in our country, in our religion, what will be happen. I come to, for example, Cyprus island. If you see here, yes, you can see border, and in northern Cyprus, if you see, we don't have so many regions. We have just the coastal parts in Lidl, but in south part we have big problem. For example, I want to show you. If we come here, as you see here, we have a lake here. They said
Salt Lake.
Limassol Salt Lake, yes. And if we don't do anything with 2,100, their land will be two parts. As you see, rough agriculture, and the South Cyprus will be separated by this one, because the two B sides of the lake will go to down of the water. As you see here, it is in the risk, and if we don't do anything, it will the land will be separated to two parts, as you see, and this one will be separated. Also, even in the Turkish part, in country of Turkey, if you come in Antalya and the other parts, you see so many parts are in the danger, they are at the risk, and if you don't do anything, so many kilometers of the land will goes down of the water. From here you can change it. Yes, sea level rise. Yes, exactly, and flood risk map. Also, it is for 21st century. If we can click on the long-term equipment. Yes, if we do it like this, some bigger one will goes like this. It is for the long term. If we don't do for a century, 2 centuries, for 100 years, we will have a problem like this. And this is just an example, not just for Turkey. In most part of the world, we have this one. For example, here, between Mersin and the other parts, some cities going completely underwater. Yes. For example, it was a good map of these impacts. Also, if you come to impacts, as I showed you, the first one that we have is this one, the temperature that we expect and we will have. You have something about the extreme weathers, as I showed you, deaths and the other things. You have health and economy, air pollution, and the other things. Also, you have about the oceans. You know, oceans are important for us because for the world heat, they are producing most of the heat, and also for oxygen. More than trees, oceans are important in production of the O2 or oxygen gas for our breath and trees breath and all the other things in the world. Also, you have about the ecosystem and biodiversity in the world. For example, you know, in the last century, we have so many problems with species. It shows here. For example, with the baseline, baseline means we don't do any policy, we don't do anything in the countries in the worldwide. It comes like this. As you say, in insects, in plants, and mammals, and in all of them, we have these dangers. Like 50% of them will be gone if we don't do anything. But with these policies, for example, as you see in the blue color, we come all of them at least to half, and it is a good strategy for us. About the impacts, we have these ones. About greenhouse gas emissions, we have all of these ones. For example, for methane emission, as I mentioned, if you don't do anything, you can see anything couldn't so impact on the methane gases. Only the policy that is so important is agriculture emissions, because as I mentioned, it is about directly about the food production and the other things. If you see, when I do this and the other policies I am doing, they are not affecting it so much. Because of that, it is so important that you know which policy is related to which one. As you see, just the waste and leakage, and especially agriculture emission can affect methane gases. After that, and methane gas is so important. As you see, there are so many graphs for it because it is so important. The methane gas is important than also CO2. NO2 you have, and also F gases that you have in productions. CO2 emissions you have here, they separated from the other gases because, you know, as you know, and we had in the slides of the professor, CO2 is directly is about the climate change, global warming. Because of that, they separated it. Also, they separated it by sources, by area, and everything. As you see, for example, here, energy and industry. You can see, which is about this one, the middle one more, and the other ones. For example, you have industry by sources and the other things. And in all of them, as I said, economic growth and population is so important. As you know, we couldn't stop population. It will become more with 2100, we are sure. Also, economic growth of the world most probably will be increased because every time World Bank reports says we have a growth in the worldwide every year. Some countries, developing countries, couldn't, but developed countries always can increase their GDP and economic growth. Also, we have the other things about CO2 emissions. We have primary energy demand and tools. These are the even for this one, I can show you this model, which we discussed before about the economic growth and carbon price. With increasing carbon price, yes, we can decrease these things. But what economic growth doing with us? When we have economic growth, we have the money to paying about the energy, so it increase this one. If you see here. Also, the important point here is renewable energy. When we have money, we can pay and we can have some investment in renewable energy, which is related with our thesis in today. So we can have digitalization and the other things in renewable energy. The other ones, but at the home and now in your workshop, please go and see all of these ones. I'm doing just an examples from these ones. Here you have the demand per each these energy supplies gases. For example, coal, oil, natural gases, bioenergy, renewable energy, nuclear, and net zero carbon ones. For example, this one, coal. Final energy consumption you have. For example, total energy sources you have here and the other things. This one, you have land, forestry, and food. Here you can do it about the forestry, agriculture, land use, and everything. CO2 removals, you have it here by the area, by the land, and the other things. Population and GDP. GDP per capita and the other things. For example, this one is about your global population. It says by 2100 we will come to around 10 or 10.2 billion people. You can increase it. For example, you say no, as I read in the reports and the other things, it comes, for example, to 11 billion, or you can decrease it. You say no, government can do something that it comes to 9.5 billion people, for example. And for exact numbers, if you couldn't do from here, you must come to this 3 dots and put it here. For example, you say 9.4. And if you click on the Inter, you can see it comes to exactly to that one. Also here you have some other graphs. For example, you can use it like this. It is, for example, by the region. As you see here, in US, it is extending. In EU, even you have a decrease in the population. In China, even you have a decreasing. India, they are managing. It is going to equal. Other developed countries, they are managing. But other developing countries, as you see in blue one, nowadays, not nowadays, in 2000, we have 2.5 for these countries only, not for worldwide. Nowadays, it is around 3.85 or 3.9 in 2025, but it goes to be 6.15 in the future, in 2100. Only the problem is in this one. About the population, we have the problem in developing countries, other developing countries, if we expect China and India. Yes, you can do like this for population and the other things. Yes, even here I want to mention the last ones. In financial part, in most of the reports and papers, it is important to mention this one. For example, carbon price, you have revenue and cost from taxes and subsidies. You have here most and so many things because you have big amount here. Why? Because we do, for example, carbon price with maximum and the other things. Even electrification, we have here the maximized. If we reduce these ones and this one, as you see, the picture will be normal. But because we maximize this one and electrification, you see it is going to a normal figure, and we couldn't do this. For example, in transportation, in worldwide, we maximize electrification, digitalization. It is we couldn't. Even developed countries like UK, United States, they are going for 2035, 2050. Not nowadays they can do. Even for the other developing countries, it is impossible to do it nowadays. So it will be like this. And if we do like this, you will have a normal figure like this one. Also, if we come to financial, we have carbon price and the other things that related directly with these policies, as you see. But in here, as I said, you can, for example, change not only the amount of the money tax, also you can change, for example, your year. You say, I couldn't start it just now. I will start it from 2035, for example. And years to achieve initial carbon price, not 10 years. For example, it took 20 years. And the other things, all of these policies you can change from here. You can mention these ones I don't have and the other things. This is about the carbon price because it is so important and so important policy even for you. Model history, I mentioned one of them for you. You can review it for yourself. Even which one is important for you by putting here, it comes to your favorite ones. And you are doing so many in the model, you can do this. And also one important thing, you can share your scenario. You can directly email it in LinkedIn, Facebook, X, or Twitter. You can tweet it. Also, you can copy your scenario link. And after copying it, you can paste in your paper, in your report. And anybody, by clicking on that, it can go to your model. For example, if I share this link, anybody, when clicking, it comes to directly to this page with my graphs, with my policies, and they can change. They can check what I did with assumption and the other things. Also, for it's finished here, but for examples that papers that the professor mentioned during his presentation, I want to show you some examples. And if you click, if you go to Google Scholar, I don't know it works or not. I want to just show you in Google Scholar some papers, for example. Yes. If you write En-ROADS in Google Scholar and click, you will see the papers like this. That, as you see, so many papers in recent years, especially from 2020, they wrote by using En-ROAD. So I want just to mention this one that you can use in your papers, even the others using this tool. Thank you so much for your attention to our workshop. We hope to see you soon in our next workshops in En-ROAD and SDGs. Also, before I forgot, we will send you a questionnaire if you are attention now online. I will write my email as a comment in the YouTube now. You will send an email that you watching the workshop and you watched. So I will share with you a link. When you filled out it, we will send you in 1 week, 10 days, your certificate by email. Thank you so much for your attention. See you soon in our next events, conferences and workshops. See you. Bye.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarını yakın. Hepimizi ileriye götür.